And go. And here we go. So welcome everybody to our live webinar today with the subject of how to build high-performing data to deliver faster new digital services architecture. So my name is Justinas. I'm a partner manager for CIS and Baltics at Exasol. And today we are presenting our joint webinar together with our partner in the region, A2 Consulting, and also with a live example of customer use case, Blockit. So over to start, the first stage, I will give it hand to Alexander Gonchar, who's the founder of A2 Consulting.
Okay. Hi, everyone. Thanks, Justinas. So there are some short rules, but I'll try to keep as short as possible to give more time to more interesting presentations, and especially our customer case, Blockit. Thanks very much for attending. So Justinas talked a few words about who will tell today some interesting cases. The main idea is how to make it work fast and easy for you. So a few words about me. At least last 10 years, I've been working with data, with digital transformation of companies, and doing about more than 200 BI projects on business intelligence and data warehouses with different tools like ClickView, ClickSense, Tableau, and some others. I'm CEO of a company A2 Consulting. We work in 6 region states, Australia, with all works done with data integration, data engineers, and BI consultants. And Exasol is another product we want to develop much, and we see here a great potential, because when we see it working with big data volumes, it's really something amazing. So a few words about our company. Yeah, we're a full service IT integrator in Europe and US about data. It's BI, data warehouse, machine learning, and predictive analytics. We do development, outsourcing, optimization, development extensions, embedded analytics, and build our own BI solutions. For example, with integration with Salesforce, Jira, Magenta, and others. We're operating more than 10 years already and have done huge part of projects. It's like hundreds. But what we want to talk today, there are main points. First point is global digitalization, especially year 2020 showed us that everything is going online, digital. And if we talk about iterations which create data, they grow from 300 in 2017 to about 5,000 to 2025. So what is important that we should know that data is becoming bigger and there is no way not to operate with it. But only data keeps as a natural resource. And if you don't do anything with it, it costs nothing. So at first step, companies just accumulate it, but the real effectivity where they can go with digital transformation when they start to use it. So the first step is they use it as analytics with different analytical tools. They change it to knowledge and discovery. And the most effective way where it happens is when business users, try to make decisions and discoveries to find out something new with common data. It's the main main 3 points how it goes and grows, because everyone is talking about accumulating data, but the most important is how you use it. If we talk about culture of every company, most of the companies, I would say maybe 60–70% used to be on the first stage, where all data governance is centralized in IT and controlled by it. Then the second stage is going to decentralization of data, where each department is a little bit isolated, but working with their own tools, data set, database, or BI tool. But what should define modern companies, or it goes directly usually to startups, where most all users have access to the data they need. As more access and easy it is to do, the better will be the decisions they make. Without systems, directly with different BI systems, but it's the main point where all companies will go faster and faster anyway, and there is like no way back. If we're talking about business value, we should define that now we go in more and more to the sphere of data economy, or each company has data strategy, and it should be combined with comprehensive analytical strategy. So I can't say that there is a company who doesn't want to analyze their clients, but the main point is whether how you combine and get all the data on customer behavior by collecting everything about inside and outside of your company, what they do. And if we're talking about outside activities, it's quite more huge amount of data. But the main point, what companies do is they try to learn more about experience, make personalization offers and suggestions to develop long-term relationship with customers. So we also come back to process of transformation, how users and businesses working with data. But on the other hand, it's also important to talk about how companies can get more of the data they have. And something is not something usual they used to do. Sometimes they need to create some new streams of monetization data where they haven't seen them before. But with modern tools and modern platforms becoming more and more used and common, especially when companies make co-branding campaigns offering a combined solution. It really works like quite a lot of cases now. So as you understand, we are a delivery partner of Exasol in Ukraine, Belarus, Baltics, and other regions. We hope maybe. The main benefit of Exasol solutions is it helps to transform the way people use data. And I would say the use of data is really important. Data-driven business with big amount of multiple sources can get it fast, easy, as we'll show later in customer case. So it helps companies to go all with modern words like artificial intelligence, machine learning, data science, and develop their environment. So again, I think you have a few words about us, and I want to give word, I think now more, and ask Carsten, our manager from Exasol and data evangelist, to show more of technology, why it's so popular and get it working fast, and then we'll go to customer case. So I think everyone, thank you. We'll go with questions later, and also some contacts on our site, Facebook, and I'll post my LinkedIn in chat so we can get connection if you have questions. Thank you very much from this point.
Carsten, over to you.
Yes, so thank you, Alexander, for this great and nice introduction. Just very briefly, who am I? Carsten Weidmann. I'm Technical Alliance Manager here at Exasol, taking care of our partners. I want to introduce you to the acceleration of data analytics with Exasol in this context of how to build a high-performance data to deliver faster digital services architectures. So when we talk about digitalization, I have to click, here we go. Basically, something I found here, and that's actually from SAP, but nevertheless, I thought it was really good because it's basically digitalization is when data from the organization and its asset is processed through advanced digital technologies and leads then to fundamental changes in business processes, and that can result in new business models and new possibilities, new opportunities, etc. Okay, so that's a nice definition, but what does it look like in a picture? Right, I'm more the visual guy. So basically what they're saying is basically we have data in all different ways and forms in our company, all kinds of different systems, technologies, internal data, external data, wherever that comes from. On the other side, we need something, or we want to do something with the data to then have different business cases, create dashboards or things like that, that actually then bring that data into a form, into a shape where we can actually actively use it as a basis for our decision making, getting new insights and stuff like that. And between these two, there's basically something where basically that magic happens, right? Where this data that has been created, as you just saw in Alexander's presentation, in what will happen from between 2017, going from 300 data points to almost 5,000 data points. I mean, that's a huge growth in terms of what each one of us will create as data and what's then available to companies to then be able to be used as a basis for decision making, for new insights, for new opportunities, and as it also said, maybe better processes or entirely changed processes. So those capabilities, what we can do with that data, apparently seem to be endless. But there's this magic. So how can Exasol actually help in such a case? And if we go back to that picture, Exasol is right there as an analytics engine that sits in the middle between these two, the input basically on the one side and the output on the other side. And first of all, Exasol as an analytics engine, it's a database that allows people to actually ingest or access that data that has been created, process it, and then visualize it on the other side, or apply things like machine learning, AI, do data science on that stuff, right? It's not nowadays, not only that we're talking about BI, business intelligence, and looking into the past. No, nowadays, as data volumes grow and as the capabilities of the technologies that we have at hand also grow, we also want to make sure that we maybe also get some predictions out of our system, or even better, maybe even some prescriptions, what recommendations, what we should do based on the insights of the data. So that is Exasol. I'll touch those six or five bullets that you see in here in a second. Very important also is where can we actually deploy this kind of system? And that's in the old days, I would say, okay, we've used that in our own data center, but nowadays, as there are so many more possibilities and also so many more flexibilities available, especially when we're looking at the cloud, where we can very easily fire up a machine and use that for some tasks and maybe then discard it to save some money, things we couldn't do before when we ran on premises. And that's where we also need to be available for the end users, for the customers. That means Exasol can be deployed very easily in any of these to then be there to provide that magic that I had in my previous slide, making it happen, creating those insights, and especially also creating those insights fast. Now, what are the three key unique selling points of Exasol? What makes it so unique? First of all, it's the performance. With our solution, we strive to be the fastest, most performant analytics platform that is out there in the world. As we know, when you run analytics, it needs to run fast. You want to start a dialogue with your data, maybe, right? You want to very quickly get to the source, the root cause of something that you see on a dashboard. Why is that bar showing red? Why is that something is so negative or so positive? So you need to be there and be able to drill into that. Maybe you also have a hypothesis that you want to prove or disprove. And that train of thought is something that you want to follow, and you need a tool that allows you to follow that train of thought and not have constant breaks in between because you have to wait and to then get to the next level, and maybe derail because you kind of like you lose that train of thought because, I mean, if you have to wait 10 minutes, what you usually do? You probably get up at some point, grab a coffee, meet another colleague, start a conversation. And when you get back to your place, the analysis is done, but you just forgot what you were actually looking for. So performance is the key thing here. The second key thing that we're pursuing is the ease of use. We want to make sure that as you have all this data available, we want to make it as easy as possible to analyze that data, to work with that data. That means there shouldn't be any tasks around that in terms of how do I have to prepare my data to achieve that performance or make it usable, right? Yes, of course, when you collect the data from all these different sources and bring that data together, you in some cases have to transform it, cleanse it potentially. Not all data is nice and clean. There are often erroneous things in there. All that true, that has to be done. But when you start analyzing, you don't want to have to care about that there needs an index to be created in order to make that query fast or something like that. So that ease of use, that auto tuning is very important for us, that you basically take this database, this tool, this digital tool, that, as I would call it, and just put in your data and you can immediately start getting insights out of it. And last but not least is that point of choice. We want to enable companies as, yes, there's definitely a path towards the cloud nowadays. Many companies are looking at, for example, at the cloud and want to migrate there. But then there is probably also some data in those companies where you say, maybe not a good idea to move that data into a public cloud where potentially anyone could access it, right? If we also look at things like the NSA still has access to every data that is stored in the public cloud because they are US vendors. That is something that people maybe do not want to have with all the data. They have maybe sensitive patient data due to regulatory reasons. They cannot move it to the cloud. So we want to make sure that these companies as well can use a tool like Exasol and maybe also nevertheless leverage the cloud for that data that is not sensitive, but at the same time have that sensitive data still on their own premises, making sure it's nice, it's secured and protected there, but allowing users to access everything, still the entire set of data, be it on premises or in the cloud, just as one. That means a hybrid approach. That is the choice that we pursue. It doesn't matter where you want to deploy a tool like Exasol. It doesn't matter where you have your data. We are there, or we can be there and can be used there. So getting a bit more technical, what are the top features that this solution has, and what does it look like? First of all, Exasol is a so-called in-memory database, or I would rather call it in-memory optimized database. In-memory sometimes has this negative attribute that, well, what happens if I run out of memory, right? That's not a problem with Exasol, for example. But in memory, we all know in-memory processing is something that is definitely fast. And we can see that also when we look at other companies, long-standing relational database management systems like Oracle, for example. Even they have now offered an in-memory option, or offering a memory option because it makes their database faster. So in-memory analytics is basically the thing where the structures that are being used inside the database have been created with looking at what do we need in memory and not how do we store data on disk. Yes, storage is still crucial. Databases have to follow the so-called ACID rules, and durability means if you write data to a database and you commit that data, that needs to be persistently stored and be there no matter what happens. The second attribute that we have is it's a column store. We didn't invent that. Neither did we invent in-memory analytics. There were other databases or other tools around there that did that. But column store is, when it comes to analytics, probably the best way to approach that. What does that mean? Usually you have a table full of data, and you have that data usually stored in rows with the columns describing the individual attributes, right? So you have, for example, a customer table where you have a column, first name, last name, address, phone number, email, whatever. Those are usually stored in rows. However, when running analytics, and maybe not running on your customer information, but more on sales or things like that, where you would have maybe a table with orders, and each order has one attribute that is called revenue or value, basically, and you want to analyze that, it doesn't make sense to read the entire row. You just want that single column, and that's why a column storage is very helpful when doing analytics, and that's why we chose it. Sybase IQ did it long before us, so we saw that this is definitely the way to go. And it helps also to compress data. That means enabling companies to use more data without having the pain of needing more hardware for that, because we can put more data into RAM, we can store more data, we can transfer more data. Compression is the key. And the last technical attribute I would say is that massive parallel processing. We have seen systems now with like Hadoop or many others where we know if we can use not only one server, but a multitude of servers and have them running processed in parallel, we can speed up those processes. And so that is something that's inherent or a feature that has always been there in Exasol. Our founders came out of research on massive parallel processing. How do I create algorithms that can leverage that multitude of servers? How can we distribute a problem onto multiple servers to do number crunching or stuff like that, and leverage the available performance, not just have to sit on one single machine and do all those complex analytics. And nowadays, we do not only parallelize the servers, but of course, we today have CPUs that have 64 cores or stuff like that. And you want to make sure that if you have one user running a query, that actually those resources really get used. So that's the MPP approach. Using as much of the available resources as possible, no matter how many users are there. The auto tuning, I mentioned that already. As I said, it's a very important feature for us because it makes things so easy when working with a solution like Exasol, because you don't have to take care of it. You just put your data model there, you put your data there, and then you start analyzing, and the database will take care of the rest. Very important. That way, you can basically leverage those resources that you initially had to administer the database and actually use them for some more value add jobs, right? Finding new data sources, defining how that data should be integrated with the existing one, what is needed by the end user, what kind of data is needed there, what could provide more insights and what's happening in the company or on the market, what could bring that company forward. So those are the things that you can then look at instead of looking at what kind of index do I need to create in order to make this report faster or that dashboard faster or stuff like that. I mentioned that data science has become more and more important, and we also saw that and integrated that into the product. That means we can enable customers, and we have quite a number of them that are doing that, running those advanced analytics, predictive analytics, or even prescriptive analytics directly in the database on the data. In the past, we usually had those two stacks, the BI data warehouse stack and the data science stack, and those were sometimes worlds apart. And one doing something on data, the other one wasn't even aware of, and vice versa. We basically, with the implementation of Exasol, we bring those two worlds together, allowing BI users actually run live predictions on their data. That means leveraging what the data science team developed as models, as insights into data, as new insights into data, leveraging that directly in their analysis and creating better, deeper insights and creating better decision. Scalability, just briefly, MPP basically inherently has the scalability. Your data volumes grow. We again, coming back to those data points that are being generated, as you can imagine, that means more and more data is generated, and you all know that probably. But also use cases get more and more complex. People want to do more with the data. We have more users accessing data. We have this data democratization that Alexander also mentioned, where you not have only the IT, but you have many different business units actively working with the data. You have more and more users to it. And so you need something that can cope with this added workload and it can be achieved by this linear scalability. That means we can enhance the system anytime needed to be able to cope with the growth. Virtual data sources. Now we know in order to analyze data, we somehow have to access it. And we saw in the previous slides with those many different source systems, one traditional step would have been, okay, we take the data, load it into the data warehouse and make it available. But for some data that maybe was not really feasible. Maybe it was changing so quickly. Maybe we just needed it for one query but then we needed the current data. So with these virtual data sources, we can integrate that data as well and make it look as if it were stored in Exasol, but actually it's a live query running on the remote system. So when you run analysis, including that data, you always get the latest status of that data without having to integrate that. Just as basically last 2 points, the connectivity thing, we're just a database. Look at a car. If we use the car analogy, we are basically the engine that sits there in the front. And we have to make sure if you change that engine, you have to make sure that the rest of the car can stay as is. And that's the same for us. We're usually coming into an existing ecosystem. You already have an existing ecosystem, or presumably, and we just have to make sure that we can nicely integrate there and work with the existing tools that you're using, and make sure that everything works as before, but just a lot faster. Like with a car, you put in a new engine, you still want to drive it the same way, have the steering wheel the same space, and everything else. But if you step on the gas pedal, you want to make sure that you actually can feel that performance, and that's what we can provide here. And last but not least, the extendability. We have integrated functionalities, the programming languages like Python, like R, like Java, which allow you to enhance the functionality of the database. So if you come across an analytics problem that cannot currently be solved with regular SQL, you can anytime enhance that capability using any of the programming languages actually you would like to use, and hence be able to run that type of analytics that you want to do that maybe the standard regular SQL database cannot do. So these are the main features around Exasol. But how can Exasol actually accelerate your data analytics? How can we make sure you get those insights and create your new architecture? Well, the first and probably easiest way would be to say, okay, we just add Exasol as an additional layer for some specific analysis, for some specific analytics that maybe need a specific performance, maybe things that run too slow in the current environment, or things that cannot be done yet, like, for example, the predictive analytics. That is basically where we just add Exasol as an additional layer. The advantage of that is your existing ecosystem stays as is. It's a low risk approach because you don't have to change anything, but it'll provide immediate benefit because you can immediately run your analytics a lot faster, do a lot more with the data. And the way you integrate the data from your existing data warehouse can be via this ETL process. That means you load the data into Exasol, but it can also be by a virtual schema where you basically don't load the data, but just make it accessible for your users. Going a bit further is, as we just saw before, we have loads of sources, and that is often also true for the analytics space. In the analytics area, we often do not only have a data warehouse, but often we have a Hadoop data lake maybe also, or something like that. We have maybe also document-based databases or NoSQL databases where we also store data, where we also put specific, maybe unstructured, semi-structured, whatever you would call it, data that you not always integrate into your data warehouse, but somehow also sometimes run analysis on it. And you want to make sure that actually you not only can accelerate the analysis for your data warehouse, but also maybe integrate that other data into your analysis. Create this one view for the end user where he sees not only the ERP data that he can analyze, but maybe also the web shop, which maybe is collected in the Hadoop data lake or in the NoSQL database, and integrate that. So that is another approach. Again, it adds benefit because it allows users to run queries across these individual data sources or data pots. but at the same time, the existing infrastructure can be left unchanged. The only thing you need to change is basically the connection from your BI application pointing to Exasol or whatever analytics application you're using, and not to the data warehouse anymore. But then last but not least, of course, we can also come in and replace an existing data warehouse. We have done that in the past. We have replaced existing Teradata installations or Oracle Exadata installations and the why are customers doing that? Because I mean, a Teradata, that's a solid product, right? So why replace that? Well, first of all, there's the performance aspect. We had a customer, we recently replaced the Teradata. And just as an example, performance is not only about analyzing data. For performance, it's also about integrating data, cleansing data, and making data available. Because the longer that ETL process takes, the longer the users have to wait for the new data. Now, in that case, for example, there was a process with data cleansing, stuff like that running. And in the end, it's basically once the data is cleansed and transformed, you integrate that data with your core data warehouse data that is actually used for analysis. So basically, you add the new data, you maybe delete data, you update data, stuff like that. That process ran in the Teradata environment for 100 minutes, 1.5 hours, a little bit more. In Exasol, we did it in 2. So you can see this performance benefit. That is something that we can actually bring to the table when also looking at tools like Teradata. Next reason for them is that flexibility, that ease of use, not needing to tune the thing anymore. It just sits there and runs perfectly fine. And last but not least, also the price. We all know these appliances, they cost quite a bit, and especially also you have to buy the hardware of the vendor, to make sure that it runs. That is not something that's the case with Exasol. You can run it anywhere on any type of hardware that you like. So these are basically the 3 main use cases, or how we can actually help you accelerate your data analytics platform, either the simple way or the simple way, fastest way as an acceleration layer, all the way to actually becoming that central analytics platform in your company, in your environment. Last but not least, I would just give a little quick overview also who we actually are. Alexander already mentioned it. A couple of numbers, put some numbers on there, but just basically who are we? And important here for me is that mission that we have. We want to accelerate the insights from the world's data and become the analytics platform that is trusted by the world's most ambitious organization. But also we have besides that vision, we have that partner vision, which is why we love to work with companies like A2 Consulting, because we know that only together with our partners, we can provide that end-to-end solution, that end-to-end implementation that can enable then companies to become data-driven and basically implement this digital services architecture where Exasol is a part of. At a glance, we went public last year. Actually, the company exists since 2000, so 21-year-old company. Last year in May, June, we went public. We have about 250 to 300 employees right now, worldwide present, but we are a German company based out of Nuremberg here in Germany. That's where the headquarters is. That's where I sit. And we have then people sitting in North America, in the UK, France, etc. Basically all over the world. And we have customers all over the world as well. To the right, you see some logos. I would assume some of them have a meaning, some maybe not. Adidas is definitely one that probably everyone knows. They are, for example, are one of those clients who do a lot of predictive analytics. They run that basically what they say 24/7 on the database, creating what they call a so-called consumer DNA, where they basically, based on the interactions of the user, again, those data points that were mentioned before by Alexander, how many we create. Again, those interactions of a user with a company, that's also a data point, right? And it's not only visiting the web page, but also receiving emails, opening the emails, clicking a link in the email, stuff like that. Those are important things that for Adidas to look at and to analyze and make predictions of. So just that's basically the company, just an extract of our customers. And as you can also see, it's not focused on a specific vertical, because I would say data analytics is something critical nowadays in every vertical, right? Everyone wants to make something better. We have a steel producer who uses Exasol to run predictive maintenance analytics. How long can we use this tool? I don't know how to call it, this pot where they have those tons of liquid steel in there. How many times can we use it before it basically we have to renew it? Can we optimize that? How can we save cost? How can we save energy? How can we have our lines up as long as possible and reduce also the number of accidents that happen in there? All that is critical, and that's why I say it's data and analytics is something that's critical in all organizations and all verticals. The market or the analysts have also a similar view on us. Bark is a German analyst, and we ranked #1 in 18 categories of their report of their analysis. In data warehouse technologies, but also in analytical database products. We get, and that's something I really love, is we get 100% recommendation rate. And our support is rated at 9.9 out of 10. We're currently looking where this 0.1 was lost. That is something that we want to optimize, because we are definitely customer obsessed. And the same thing has also been said by Dresner. In Dresner, these 100% recommendation rate from our customers, actually we got this 4 years in a row now. And as you can see, we are a leader both for customer experience, but also credibility that up there, and we provide most value and best. People have the most confidence in us when looking at this. So this is a very brief. I hope I got was able to take a bit on this journey of digitalization and how we can help there, and who is actually behind it as a team. As a company that we're not necessarily new to the market, but we have been there for a while, and we know what needs to be done, and we can provide that technology to actually make your analytics experience a lot better and get you more insights and help you to create this new digital services architecture, this data architecture, become data-driven as a company. With that, I hope I didn't exceed my time too much. I know I sometimes talk a lot. In case there are questions, please either ask them now via chat, or alternatively, I would say we probably after, and that's the most important and most exciting presentation, what Blockit will actually say about their data platform, how they're doing data analytics. So with that, you have my email address here. Thank you very much for joining today and for listening in. And now I hand over to Johan, who can tell us a bit more about what Blockit's doing.
Thank you very much. Let me see. I will share my screen. There we go. Yeah, so my name is Johan Verlander, and I work at Blockit, and I will talk a little bit today about how we use Exasol and what we like about Exasol, and in this particular case, especially about working with JSON data in Exasol, which is a very flexible way of ingesting data and being able to process what you want without having to decide in advance. So for a bit of an introduction, I work as a lead data engineer at Blocket. I've been in data warehousing, data engineering since about 2012. And before that, I was a DBA, ERP developer for a bit, and worked a lot with infrastructure automation. I've done a lot of sysadmin and infrastructure in general, and originally came into the IT business, working support and help desk. And as for Blocket, it's now one of Sweden's leading marketplaces, but was founded in 1996. So it's been around for a while and was just a local marketplace for a single region in Sweden at the time. It soon expanded to the rest of the country and has been exported to many other countries as a concept. Not necessarily under the same company, but as a concept and a starting point for marketplaces in other countries. So this talk then is about why we chose Exasol, where Exasol sits in our data stack and what the rest of the stack looks like, and a lot about our JSON use case. What I will be discussing mostly is our front-end tracking data and how we process that. But we also use JSON data ingestion for REST APIs and Kafka as well. And what's on our horizon going forward. So, Exasol at Blocket. Why did we choose Exasol? Well, many years ago, we used to have a Postgres database actually for analytics on premises. And I can imagine that it was a bit painful. I wasn't there at the time, but I know that Postgres isn't really super well built for analytics specifically. A lot of things that you expect to be fairly quick to run doesn't really run so quick in Postgres. It is excellent as an operational database though. But anyway, eventually we decided, or Blocket decided, that it was time for a cloud migration. So all of the data analytics moved to AWS. And at that point, we decided what should we use for database? Well, there's Redshift, of course, which was the main competitor at the time, at least. And then Exasol that we compared. And Exasol had about 4 times better performance for the same cost at the time. And it was quite an easy decision, I would say. We started out with a pretty small instance, just 50 gigs of RAM, one node. And it got us pretty far. But in 2018, a year after I started, we decided it was time to scale up. And last year, we went from 200 gigabytes to 1 terabyte of RAM across the same number of nodes, mostly to be able to accommodate more of our detailed data, not having to aggregate everything too much, and be able to consider ingesting a bit of our front-end tracking data as well. So, what were the benefits then? Well, we came for the better price-performance ratio, and for a database or analytics database that was very easily managed, no index maintenance, hardly any administration. But now we're also discovering that there is a lot of benefit in the plugins and the connectors that simplify our ETL processes. For Kafka and for Postgres, it's just an import from statement to get the data we need. We have virtual schemas that allow us to very easily explore the data sources that we have without having to specifically set up accounts and access all of them via database clients on each analyst machine. And the Json processing that we started using enables lossless data ingestion where we want to have it. So we basically store all of the incoming data, and we pull what we can, what exists as JSON in a varchar column. And then we run transform processes within Exasol and just extract what we actually need for the moment. And later on, it's easy to go back and just pick up whatever we think we might be missing. given that it exists in the incoming data, of course. But the critical point is we don't have to throw it away. We can keep it in the staging table as in JSON format. So our data stack has been through a bit of an evolution as well. And what it looks like right now is that we, for orchestration, we run mostly Apache Airflow and Databricks, where Airflow handles most of the backend data, and the Databricks is a way for us to partly to enable analysts to have self-serve access to the front-end tracking data, which sits in AWS S3. And also it exists as a way for the analyst to be able to schedule jobs easily to run in Exasol. It's maybe not like a core use case really for Databricks, but it works pretty well. They can connect to Exasol, run some SQL, and then the notebook will shut down, and the cluster that you use will eventually shut down when it's not being used anymore. So it does work. Our main pipelines usually pull some data from S3 buckets, from databases, mostly Postgres, and REST APIs, which can be both external APIs and internal ones. And increasingly, we're using more and more data that's coming in via Kafka, especially for the internal microservices. All of this is scheduled, as mentioned, in either Airflow or Databricks. And Airflow, when it starts our ETL tasks, starts them as Fargate tasks, where we can, it's basically just a Docker image, so we can run Python or SQL or anything. And for the Databricks notebooks, of course, PySpark or SQL directly inside Exasol and so on. And then we load all of the core data into Exasol. And we have experimented a bit with building some prototypes as delta tables in Databricks and connecting eventually Tableau to that. And it does work, especially for analysts to easily have something up and running. But Tableau is definitely much faster when it connects directly to Exasol and can make use of that performance. So of course, with a lot of data, you have to do some monitoring, and naturally we have alerts on our pipeline failures, email and or Slack alerts for our Airflow tasks and for the Databricks jobs, so that they will notify us when something goes wrong. We have a data quality dashboard that is monitored in Tableau, mostly by our analysts. And it's an aggregated table of some quality metrics for the critical tables in our data. And then we also are experimenting with Redata, which is a system basically built to sample data from pretty much all of the tables in the data warehouse and monitor trends over time. So you will see if you have missing time periods where it usually sees that you actually tend to load, like if you tend to load data every hour and suddenly there are a few hours missing, you will get an alert. If suddenly you get twice as much data as you usually would, you will get an alert, or if the percentage of nulls in the data increases and so on. So it's still very much in the work in progress part, but it looks promising, and I hope that it will help us to keep an eye on all of those, the long tail of data and tables that are not considered super critical enough to be monitored by the analysts. So how do we use JSON in Exasol then? Well, to begin with, the JSON support for Exasol started appearing as opt-in in Exasol 6.2.7, which is when we started using it. And it's enabled by default in Exasol 7, which we have now, with really nice documentation. So it's fairly easy to figure out how you need to work with the data. You can do single value extraction. So for example, if you have a JSON object, you can just call JSON value on that column and add an JSON path expression and pick out a single field very easily. But what we use mostly is actually multi-value extraction using the JSON extract function, where we can pick out any number of fields in the JSON data that we want to extract. And even, for example, like in this particular example, the JSON extract will actually iterate over the customers array and generate one row for each entry, picking out the name and the phone numbers, phone number type, and so on. So that's really nice when we have APIs that return very nested data sets. So it's pretty easy still to get them out, even though they would be very difficult to handle from a relational aspect otherwise. So what about our front-end tracking then? Well, we have a system called Pulse that is a Schibsted system for tracking front-end events. And all of those page views and UI clicks and logins and all of that eventually end up as batches of event data in S3. What we have been doing is that we're ingesting this data using PySpark jobs with PySpark filters and transforms that apply all kinds of complex rules to identify our lead signals and particular types of events that we want to analyze. And then we have been writing this aggregated data to Exasol. The problem with this is that when you actually want to troubleshoot something, then it's kind of tricky. You have to find the problematic job, of course, extract core bits of the code to a troubleshooting notebook, perhaps, look at intermediate results in PySpark, trying to figure out what actually is the difference from when it did work. Yeah, bang your head against the keyboard and repeat until hopefully you have something that works. It works, but it takes a long time when you have to go through all of this. And the problem is partly that the source data that we use has a weird layout. We can't map it directly to a table in Spark without extracting the fields anyway. We have quite a few events. I'm seeing here 100 to 150 million. It's closer to 150 to 200 million now, I think, of events every day. And usually in Databricks, when we run our PySpark processing, it will be 10, 20, maybe even 30 minutes if we want to process one day of data to inspect and see what's going wrong. It's also hard to get the proper context when you're looking at data in isolation like that, because we can't join it with what we already have in Exasol. So if we do want to verify the end result, we usually have to run the Exasol import as well, which takes another maybe 10 minutes or so for that day of data. And then we have to repeat all of that for every attempt to fix the data flow. So this seemed like a good candidate for trying out the JSON support. We thought that, well, what if we just load all of the events into Exasol as they are? And the idea was that we have a minimal PySpark job that just extracts some of the more commonly used fields and then stores the full event record as a JSON field. And then we load this daily into Exasol and we delete any data that's older than 30 days. So we have some historical context, but not enough that we have to pay all of our money to Amazon for the EBS storage. And it worked really great, actually. It's a lot easier. You can run just SQL queries against the data instead of having to figure out the proper PySpark code, which is, I mean, if PySpark is what you're using every day, of course, that's not too bad. But for us, we're using mostly SQL and PySpark is more of the exception. It's definitely a lot faster. If you can use all the already extracted columns in the raw data, it runs at the regular Exasol amazing analytic speed. If you do have to dig into the JSON, it's a bit slower, but definitely faster than doing it in PySpark notebooks, where you have to stop and start clusters and distribute the computing job across the cluster and wait for the results to come in and all that. It's a lot richer. since we can join it with the existing tables. So we can at once see, what, okay, so if we try this a little bit differently, will it work better? Yes. The problem is, of course, there is a lot of data, for us at least. Each daily CSV import of this raw pulse data is about 400 gigabytes uncompressed. And we had to scale our EBS volumes from 8 to 24 terabytes, which of course includes replication and things like that. And it did have an impact on database RAM usage. 6 billion events and 16 terabyte raw table size for 30 days. Though, fortunately, with the compression enabled, it ended up being just 2.3 terabytes. And as you can see from well, what would that be? I guess September to October, when we started working with this, the database size increased quite a lot. Definitely the blue line, the raw database size. Some of the things we learned about this was that with these runaway table sizes, at least in Exasol 6, we needed to run and recompress and force manually to get the most efficient compression. We could, of course, have expanded the disk a bit more, but we decided it's fine. We'll probably try to relax on this a little bit and see how it works. But right now we run this on Sundays. It takes about 5 hours and it doesn't bother anyone. So yeah, it's fine. Regular expressions, interestingly, beat UDFs every day of the week when it comes to performance. We tried to do some of the processing of this front-end tracking data with Python when we wanted to parse timestamps and things like that. And the Python solution, of course, was a lot easier to work with, but it took 2 to 5 times as long to process the data. So, well, we use weird regular expressions instead. And Exasol definitely could benefit from a wider variety of natively implemented string functions, splitting rows by separator or regular expression, extracting by separator or extracting by regular expressions, and maybe even some nice schema discovery UDFs for JSON columns. I have experimented a bit with it on my own, so I might contribute something if I can find some nice place repository that Exasol has that we can put this in. But yeah, we'll see. So, what about the other JSON use cases, REST APIs and Kafka? Well, since we've already expanded our use of JSON to all of the new REST API extraction jobs that we have, it makes the code a lot simpler when we do our extraction. The only thing it needs to worry about is to pick up what is usually already the JSON output from the REST API and store it in a column in the database. And then we can worry about later in the SQL transformations what we want to do with it. As for Kafka, our legacy pipelines, which we still run some of, they run a Python Kafka consumer writing CSV data to S3, and then we do a parallel import from S3 to Exasol. And that is it's kind of slow. It could definitely be done differently, I guess, if we wanted to spend time on re-architecting it. Right now, we just usually run one Docker container as an Airflow task for each Kafka consumer or for each Kafka ingestion job. So it doesn't have a lot of performance to work with. But what we decided to start doing instead is just import using the Exasol Kafka connector and store as a JSON doc column. And then we transform it to a final model using dbt, which I will get a bit into later. And as you can see, it's not too difficult to set this up and to do this. And as for the import part, we already have a connection object defined with all of the bootstrap server, schema, registry details, and so on. So everything that you actually have to specify in the import is just the topic name and what table you want it in, and so on. So this has been a really, really nice experience. And of course, with with a 4-node cluster for Exasol with fairly beefy machines, we get a lot better performance as well. I actually did a test earlier today, or it was yesterday, and I managed to ingest about 16 million rows in, I think it was 3 minutes or something like that. So it was fairly decent speed, and I haven't really been working very hard on trying to optimize all of the Kafka configuration parameters and so on. And I don't have any idea really how well specified the Kafka cluster is. I do suspect that our Exasol cluster is a bit more powerful than the Kafka cluster, so that's probably the bottleneck. So our conclusions about working with JSON is that as a format for raw data ingestion, it works really, really well for us. The source schemas can change freely. It doesn't actually halt the ingestion pipelines. And the extraction jobs become a lot less complex, especially when we're doing the REST API extraction. You could almost have a generic REST API instruction module and just work with that. But of course, it depends on other factors, as some services may have different types of authentication and all that. And with some Exasol improvements, this could be an obvious choice going forward, I think, for pretty much anyone. Having import UDFs uniformly allowing to fetch a full row as a single JSON doc column, which already works for Kafka, would be really nice to have in the cloud storage extensions as well. So we could do it the same way when we import from Avro files or Parquet files or similar in S3. And it would be really nice, of course, if Exasol eventually evolved the treatment of JSON data so that it can be treated as semi-structured, which would probably reduce storage size by using columnar compression for the JSON fields and would enable statistics and indexes on at least the common fields across a data set. So what about the future for us then? Well, we already have, as of a few weeks ago, Exasol 7. So that has been a great step forward for us. We are starting to make use of the new features. We need to convert various varchar columns here and there to hash type to get better performance and improve storage utilization. And we can also start working with the new ISO 8601 support in 2 timestamp, where it can actually convert timestamps with a UTC specifier, which we so far had to work with the regular expressions to handle. We'll work more with JSON data, of course. For most of the data that we extract, we'll probably use that as a storage format. I would say that the exception would be that if we have some data sources where parts of the data model are sort of sensitive data, we'll probably extract it field by field from the beginning so that we can easily anonymize and purge sensitive data like that without having to delete the entire JSON blob. We are in the process of migrating to DBT for transformation jobs in Exasol. It's not something that I did get into a lot here in this presentation, but if you haven't heard about it or looked at it already, I can really recommend it. It's basically a way to build your tables and aggregations in the database, but just based off of pure SQL queries. So you define a module as an SQL query, and then DBT takes care of creating the table for it and all that. And you will get lineage information, and yeah, it's has been a really nice experience. And it's also starting to enable more analytics and BI participation in the data pipelines. We're just starting to onboard our analysts, and I think that it will help them a lot in not being dependent on getting engineering help to put models into production. We need to finish working to set up redata for data monitoring. so that we can catch various weird issues that always happens every now and then, things that don't look quite right but aren't actually failing, and to have some scalable detections of the issues that we have in our so-called non-critical data. Because I mean, as we all know, it's just non-critical until you find out it's used in half of the management dashboards. As for our infrastructure, we have traditionally been managing it with a mashup of CloudFormation, Ansible, and manual setup. And we are now migrating to Pulumi, which is infrastructure as code, but for actual real programming languages. We use Python, but you can use TypeScript, Go, .NET, and a couple of other options now, I think. So yeah, that's also been a real improvement in our data stack lately. Well, thank you all very much. That was it for me.
Thank you very much, Justinas. Maybe
Excellent. Yes.
you can make a final word.
Just to make it a final word out of this presentation, thank you so much, Johan, and thank you so much, Carsten, for the great detailed review of your experiences and introduction and the value of Exasol. Now, as a final step for everybody who's attended, you may have an opportunity to ask any questions that you may have. So you can use your chat. Right.
Well, anyway, we can get questions later. Yeah.
Yeah. Maybe I can use not chat, but to Carsten, I have a question about replacing data warehouse. You showed the slide and showed that there were some virtual schema, and I want to ask maybe more words about it. What does it mean, and how many efforts does it take to make it and change the previous architecture for it?
Right. So the virtual schema is actually a rather simple approach. So what we do is all you need is a JDBC driver for the database you want to integrate. So start the simplest case, put it this way. The initial or simplest case would be to integrate another relational database management system. So like the Postgres that Johan mentioned, or Oracle or SQL Server. And then all you need is a JDBC driver for that database. We have a GitHub repository for these databases where we basically have implemented support for the individual dialect of these databases. And then it's basically 5 lines of code in the database, and you have that integrated. That means, for example, with an Oracle, if you want to integrate an Oracle, you pick one schema of that Oracle, and that schema will then show up as schema in Exasol. That means from a user perspective, it looks like a local schema, local tables. But what happens as soon as you query that part of the query that accesses data in those virtual tables will be sent down to the source system. In that case, then the Oracle will be executed there. Data will be brought back. We try to push down filters. We will do a join push down, stuff like that. Everything that's happening on that remote database will be pushed down also reduce the amount of data that needs to be transferred back. Of course, a bad situation would be if we want to join 2 tables from 2 different virtual schemas, for example, with no filters. Then we would need to pull in the data of both tables, or the join columns of both tables, to make them be able to make the join and then fetch the other data. So that would mean loads of data being transferred, but that's the very simple way. What you can also do if you go a step further is to integrate something like a NoSQL database, say DynamoDB on AWS or MongoDB. What we need there, in addition to that connection, is basically a mapping, because we have to define, as we are working then with JSON documents, and they can be complex, they can be nested arrays inside. We have to define how do we want to present that content of those JSON documents in Exasol. Do we just want to have one and the nested content as another JSON stuff, or do we actually want to split out that document and create a real data model that we will use and then query? So that are things that have to be decided, but that can then also be implemented very quickly. We just have to define the mapping, what field in the JSON document represents or what object represents a table, what attribute represents what attribute in Exasol, and so on. And that's it. And then you can basically connect anything else. We also have on GitHub, and that's github.com/Exasol. We also have a virtual schema for a REST API. In that case, we connect the Open Weather API as virtual schema. That means the API looks like a table or a set of tables that you can query via SQL, and the connector then translates that into REST API calls towards that REST API. So that's the way of to use those virtual schemas and integrate data. Of course, when you migrate from or replace an entire data warehouse, there's many steps, and depending on how the original data warehouse has been set up, of course, also there might be some effort in there to actually do the migration, right? If you have an Oracle warehouse with, I don't know, huge framework of stored procedures in PL SQL for your ETL jobs, that migration might take longer. As if you have, we just had that Teradata migration, I was talking about, they were using Warescape for data warehouse automation. For them, it was rather easy because they just pointed Warescape to the new destination, Exasol instead of the Teradata, and that was pretty much it. And they were done, right?
Yeah.
So that's the and that's why
the idea. I understand the idea. Yeah. Okay. Okay. Thank you.
Very good.
And I guess it will be some other additional series, conducted by Carsten in the future with regards to Teradata migration practices. So anybody is expecting to participate, either expecting to do it internally, or you're looking to become a partner of us, to do that practice. So by all means, you can contact Carsten with any questions you have, or to find out what the schedule is for the